In the previous section, we have learned how to find the minor and the cofactors of the matrix. So in this section, we are going to learn how to find the adjoint matrix. Now, let's say after we find all the cofactors, and we put the cofactors in the form of matrix, so we call this the matrix of cofactor. Okay, so this is the original matrix, the matrix A. So after we find each cofactor respectively, so then we put them as a matrix. Now when we have this cofactor, matrix of cofactor, and we transpose it, we can find the adjoint matrix of A. So what is transpose? Now the transpose means that we change the column to row, or we change the row to column. Alright, now let's see here. Now this is the first column. Sorry, this is the first row. We have C11, C12, and C13, the first row. Now when we change the first row to the first column, so this process is called transpose. So you can see here C11, C12, and C13 now become the first column. And the subsequent row, right, C21, 22, and 23 now become the second row, become the second column. And the third row now become the third column. So this process, we call this transpose. Right, so when we transpose the matrix of cofactor, right, the answer we get here, the result we get here is called the adjoint matrix. Okay, so let's continue with the example we have in the previous section. So we have this matrix, and we now want to find the adjoint matrix of this. So from the previous example, right, we have found the cofactor matrix. So the matrix of cofactors will be this 4, -2, 2, 4, 12, 2, 3, 9, 5. Now to find the adjoint matrix of this, so this is what we do. We transpose the matrix of cofactor. So this is what we do, right? The first row now become the first column, right? So we have 4, -2, 2, and then the second row become the second column, and the third row now become the third column. So this is called the adjoint matrix. Okay, now please note that even if you change the first column to the first row, it will still be the same matrix. So 4, 4, 3, so you can see 4, 4, 3. So if the second column changed to the second row, it will be -2, 12, 9. And the third column changed to the third row, 2, 2, 5. So it doesn't matter whether you change the row to column or change the column to row, it will be the same answer. Therefore, for transpose, you can interchange the row to the column. Next, we are going to learn how to find the determinant of matrix. Now, the determinant is a real number associated with a matrix. Only square matrices have determinant. Alright, so now the determinant, this is the symbol we use. Okay, can use this. Alright, two straight line, alright, or modular sign. Or we can actually use this symbol, right? DET, then bracket A, right? Stand for determinant of A. Alright, or okay, we can actually this is the common way to use it. Okay,
Now, so this is the matrix 3, negative 1, 2, 4. So to find the determinant, we just put 2 straight line. So this is the determinant for matrix 2 by 2. Now, if you pay attention, you realize that before this, when we try to find the cofactor, we are actually using this sign. So this actually shows that this is a determinant for the matrix after we reduce the 3 by 3 matrix to the smaller matrix, 2 by 2 matrix. So this is actually the determinant. All right, so now determinant only applicable for square matrix. Now, what does a square matrix means? Square matrix means that the matrix is in a square form, right? Now, as you can see here, this matrix is not a square matrix. We have 2 rows, 3 columns. Therefore, right, the determinant doesn't exist in this type of matrix. Okay. Now, how to find the determinant? Basically, right, to find the determinant, you select one row, okay, only one row or one column. Now, it can be any row or it can be any column, but just one. All right. Now, let's say if I choose the first row, right, I choose the first row. Now, I'm going to take the element, multiply the cofactor of the element. So it will be the first element multiplied with the first cofactor plus the second element multiply the second cofactor plus the third element of the row multiply the third cofactor. All right, so this is how we find the determinant. Let's consider this example. All right, now for this example, right, if we take the first row to find the determinant, so this is what basically we do. So we take the first number, first element, which is 2. Then we find the determinant, we find the cofactors. All right. So now the cofactor, so we are going to take the reduce the matrix 1, negative 5, 2, 4. And for this cofactor, right, the sign is positive. So it will be a positive sign. Okay. Then after that, we move on to the second value, 0. Right. So we delete the row, we delete the column. So we have negative 3, negative 5, 0, and 4. And this is the minor. And for this element, the cofactor is negative sign, right? So it's a positive, negative, and positive. So it's a negative sign. Therefore, we put a negative here. All right. So the negative actually multiply with this positive and it become a negative. All right. So by right, according to the formula, it should be a positive sign. But however, this positive sign, when we multiply with this negative sign from the cofactor, it become a negative. All right. So please take note that according to the formula, it should be a positive sign. All right. And now then we plus again. Now we are going to take the third element, all right, which is 5 here. So we delete the row, we delete the column. So this is the matrix, negative 3, 1, 0, 2. All right. And for this element, the sign is positive. So therefore it will be a positive here. All right. So now after that, all right, so we are going to proceed with the calculation. So we are going to start with this one. Okay, so we have 1 times 4, yeah, and minus negative 5 times 2. Okay, minus negative 5 times 2, and multiply the 2 here. All right, after that, negative, all right, 0, And negative 3 times 4 minus 0 times negative 5 plus 5, negative 3 times 2, 1 times 0. Okay, now finally, when we solve this one, so this is 14 times 2, 28. Now, since this is 0, so the whole thing will be 0. And the third one, we have negative 30. All right, so the determinant is negative 2. Okay, now we are going to use the previous example now to find the determinant. So from the previous example, from the previous calculation, we actually have found the matrix of cofactor, right? And this is the matrix of cofactor, right? So in order to find the determinant, so this is what we do. You can choose any row or you can choose any column, but we only choose one. So usually this is what we do. We try to choose the column or the row with 0 or with the smallest number. All right, so now let's say we choose the first row. Okay, so the first row, right, this is the elements and this is the cofactors. So we will have 3 times 4 here, negative 1 times negative 2. All right, take note that this is plus. All right, and 0 times 2. All right, so solve this one, we have 14. Now, we can also use another column or row to calculate the determinant. Now, let's say I actually found that this column is easier. All right, so we have this one. The second column, all right, then we choose the respective second column in the matrix of cofactor. So this is what we do. The determinant will be, right, if we let this one be A, matrix A, then the determinant of A will be, right, negative 1 multiply negative 2 plus 1 times 12 plus 0 multiply 9. All right, so this is 2 plus 12, 14, and this is 9. So we have again 14. So actually, I just want to show you that now, regardless of which row or which column you choose, if you use the correct method, all right, you will actually get the same answer. So choose the smallest number, right, and those with 0, right, to perform your calculation. Now, we have actually another way to calculate the determinant of the matrix. So this is the example. So let's say we have a matrix like this. All right, so we want to calculate the determinant. So first we can actually multiply these three numbers, negative 3 times negative 1 times 6. So we get 18. Then we have 3 times 4 times 5, which is 60. 4 times 2 times 2, all right, which is 16. All right, now after that, we can also take the multiplication downwards. All right, 5 times negative 1 times 4, so this is negative 20. 2 times 4 times negative 3, negative 24. 6 times 2 times 3, positive 36. Now finally, this is what we are going to do. We are going to sum this, all right, negative 20 plus negative 24 plus 36. So the answer we get is negative 8. So put the negative 8 here. And again, we are going to sum this 18 plus 60 plus 16. So we get 94. And so we are going to put this one here. Okay. So when we use the sum of the multiplication downwards minus the sum of the multiplication upwards, so we will get the determinant. All right, so you can actually use again this example to find the matrix, right? Using this method, right? You will get the same answer, which is 14. Okay, now in the following discussion, we are going to talk about identity and also some introduction about the inverse matrix. Okay, now, so what is the identity matrix? Identity matrix is a square matrix that has ones along the main diagonal and zeros everywhere else. Okay, so in this case, the identity matrix actually need to satisfy two conditions. The first one, right, it must be a square matrix. All right, remember a square matrix, should be 2 by 2 or 3 by 3. So these are square matrix. All right, so it must be a square matrix. Now the second condition is that all the diagonal values, so this is called the diagonal values. All right, so all the diagonal values must be 1, all right? And other than that, all are 0. All right, so we call this identity matrix. Now, what does it mean by identity? Okay, let's take a look on the example of some other identities. Now, we know that, okay, for addition, all right, any number, if you plus 0, you will get back the number itself, right? Therefore, 0 is said to be the identity of addition. Okay, so 0 is the identity for addition. Now, how about multiplication? Any number, multiply what number will give you the number itself? It's actually 1, right? Therefore, we say 1 is the identity for multiplication. Now, the same concept applies here. When we say identity matrix, it means that any matrix, if we multiply the matrix with identity, you will get back the matrix itself. All right, so when you multiply a matrix by identity matrix, you get the original matrix, which is A. All right, so you can actually try, right? If you take a matrix 1, 2, 3, 4, multiply 1, 0, 0, 1. Now, so we are going to start with the first row and multiply the first column. 1 times 1, which is 1, plus 0. 2 times 0 is 0. Now move to the second column. 1 times 0, 0, plus 2 times 1, which is 2. Now move to the second row. 3 times 1 is 3, plus 4 times 0, which is 0. And the second column, 3 times 0, which is 0, plus 4 times 1, which is 4. Therefore, we are going to get 1, 2, 3, 4, the original matrix again. All right, therefore, all these matrices are called identity matrix. Okay, next. Now, inverse matrix. Now, inverse matrix is related to identity matrix. So, now how do we define inverse matrix? Now, let's say we have two matrices. All right, this is matrix A and this is matrix B. Now, when matrix A multiply matrix B, we get identity. So we say matrix B is actually the inverse matrix of A. All right, so matrix B is the inverse of A, and also matrix A, it is the inverse of B. All right, so this is how we define the inverse matrix. So when we two matrices, the multiplication, we get identity, then they are the reverse matrix. So they are the inverse matrix of each other. Now, one important note here you must know, if the determinant is 0, then the inverse matrix does not exist, right? Okay. Now, to find the inverse matrix of 3 by 3 matrix, this is what we do, right? So we are going to use this formula, 1 over determinant of A multiply the adjoint matrix. So the adjoint matrix is the transpose of matrix of cofactor, and determinant can be found using the cofactor and the elements of certain row, one row or one column. Okay, now let's continue with this example, the previous example. So let's say the matrix, this matrix is defined as matrix A. Now we want to find the inverse matrix of A. So from the previous example, we actually found that the adjoint of A is this. Okay, so hope you still remember from the previous example here, we actually have the determinant, all right, and the adjoint matrix of A. Okay, so now apply the determinant is 14 and the adjoint matrix of A into the formula. So 1 over determinant, which is 14, multiply the adjoint. So this is the inverse of A. Now you can actually leave your answer like this. You do not have to multiply. All right, as if we multiply this value, it will be this will be 2 over 7, right? Which all are fraction. So to make our answer easier uh, to be used later, all right, you can actually leave your answer like this. So this is the inverse of A. Now, why do we need to find the inverse matrix? Now, in the following discussion, we are going to learn how to use the inverse matrix to solve the system of linear equation.